Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to the third lesson about addition polymers. In the last lesson, we learned about polyvinyl chloride, commonly known as PVC. We also learned about polymethyl methacrylate, which is better known as Perspex. We learned their properties, their chemical equations, and some of their uses. Today, we will study two more addition polymers, polystyrene and polytetrafluoroethylene, which is better known as Teflon. Are you ready, students? Let us get started. We will begin by discussing polystyrene. Polystyrene is an aromatic polymer made from the monomer styrene. Aromatic in this context means that its molecules are unusually stable because of the arrangement of its atoms. Polystyrene is therefore one of the most commonly used types of plastic. It was discovered in 1839 by Edward Simon, an apothecary in Berlin. It began being manufactured commercially in 1931. It is a thermoplastic substance like PVC and Perspex. Pure, solid polystyrene is a colourless, hard plastic that does not have very much flexibility. It can be transparent or dyed different colors and can be cast into molds that have a high degree of detail. It can also be foamed to produce a light, soft material that is better known as styrofoam. Polystyrene can be used in CD and DVD cases, models, and disposable cutlery, to name a handful of examples. Its foam form is even more common. Foam cups, insulation, and packing material can be found everywhere in the world. Polystyrene can be recycled, although it is so inexpensive to produce new polystyrene that it is not recycled as often as it could be. It takes an extremely long time to biodegrade and is one of the primary forms of solid pollution. It is particularly common along shores and waterways as its density is so low that it is carried by tides and water flow. This is the monomer for polystyrene. It is called styrene and is a liquid hydrocarbon that is commercially manufactured from petroleum. I'm sure that you remember from your previous lessons that a hydrocarbon is an organic compound made entirely of hydrogen and carbon. Let us pause for an activity, students. I have told you a great deal about polystyrene. I wonder how much you remember. Please, look at the following statements and fill in the blanks. Do your best, everyone.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. If you have been attentive to the lesson so far, you will have had no trouble with this exercise. The first statement says that polystyrene is an aromatic polymer made from styrene. Remember, in organic chemistry, the word aromatic refers to when a substance's atomic structure is unexpectedly stable. The second statement says that solid polystyrene is a colorless, hard plastic that does not have much flexibility. The third statement says that, regrettably, because it is so inexpensive to produce, polystyrene is rarely recycled. Were you able to fill in the blanks? Good work. Let us continue with the lesson by studying Teflon. Teflon, known by the chemical name Polytetrafluoroethylene, or PTFE, is a synthetic fluoropolymer. It has many applications, mainly because it has one of the lowest coefficients of friction of any known solid. It was accidentally invented by a man named Roy Plunkett in America in 1938. While he was attempting to make a refrigerant, he polymerized the gas tetrafluoroethylene. The resulting compound was found to be oddly slippery. His company, Kinetic Chemicals, patented the compound and trademarked it as Teflon in 1945. Teflon is a fluorocarbon solid, which means that it is a compound of high molecular weight that is made almost entirely of carbon and fluorine. It is hydrophobic, meaning that it does not get wet when exposed to water. It is very non-reactive, partly because of the strength of the carbon-fluorine bonds. It is best known as a non-stick coating for cookware because it has such a low coefficient of friction. Teflon is also used in containers and pipework for reactive chemicals and as a lubricant for machinery. Teflon also has excellent dielectric properties. This means that it is often used as an insulator for cables and connector assemblies. It is particularly well suited to this task because it has a very high melting point of 327 degrees Celsius. We have learned about both polystyrene and Teflon. Now it is time for another activity. Students, please write the chemical equations for the polymerization of styrene and tetrafluoroethylene. You may work with a partner to complete this exercise.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to complete both of the equations accurately? Here is the chemical equation for polymerization styrene. And this is the chemical equation for polymerization tetrafluoroethylene. Check your equations against these, students. Are they identical? If so, great job. Today, we have learned about two addition polymers. We have learned that polystyrene is a common and useful plastic with many applications. We have also learned about Teflon and how it has one of the lowest coefficients of friction of any solid. I hope you have enjoyed this lesson as much as I have. That is all for today. Until next time, thank you, teacher. Thank you, students.